Hello everyone. Today I will be discussing how mariculture and integrated multi-trophic aquaculture, or IMTA, can improve upon the sustainability of aquaculture practices. You might be wondering why improving aquaculture sustainability should be prioritized. Well, overfishing is unsustainably depleting a third of the world's studied fisheries, which approximately 3 billion people depend upon. Even in the absence of fishing, many fish populations cannot produce enough replacement spawners to restore their populations quickly. Also, bycatch species are either accidentally caught alongside targeted species, discarded, and often die, or they are hurt and killed by encountering fishing equipment. Bycatch numbers are not tracked even though fishing drastically reduces their populations, so the decline is often unnoticed. Therefore, increasing fishing is not a sustainable solution to meet the global demand for seafood as the human population increases, and this is where aquaculture comes in. Aquaculture provides around half of the global demand for seafood, as you can see in the image to the left, but it faces sustainability hurdles as well, such as pollution of chemicals and waste, the spread of disease through farms and into surrounding ecosystems, the use of freshwater resources, escaped fish killing or breeding with local species and creating competition, and degradation of coastal ecosystems and mangrove forests to support aquaculture ponds. These hurdles will need to be addressed before aquaculture will be sustainable. In one case study, scientists observed 30 years of change in the mangrove forests of the Mahakan Delta in Borneo, using 6 Landsat image series as you can see in the images above, and they noted that by the late 1990s, 41% of mangroves have been converted into ponds, and by 2020, 54.8% of the Mahakan Delta is covered in aquaculture ponds. Mangrove forests are needed to filter out pyrite, but the mass conversion to aquaculture ponds left the area with a weak filtration system, causing pyrite poisoning where many of the ponds lost half of their productivity. So restoring the mangrove forest is the only way to increase the coastal aquaculture productivity again. Mangroves are effective carbon sinks, protect coastal areas from extreme weather and sea level rise, are nurseries for biodiversity, provide essential natural resources to local communities such as food, wood, and water sanitation, and boost local and global economies. So restoring these mangrove forests is essential to coastal sustainability. The human population is projected to reach 11 billion by 2100, and it is estimated that around 41% of people live within 100 kilometers of a coast, so simply reducing these unsustainable aquaculture practices will not be enough. More sustainable aquaculture solutions need to be implemented to reduce the pressure they create on coastal ecosystems and economies. One solution is increasing mariculture, which is offshore aquaculture in deeper waters, often using a type of underwater cage as shown in the image on the right, so there is significantly less coastal ecosystem impact than an aquaculture farm that is positioned on the coast itself. However, many of the same environmental impacts are present and pressure the marine ecosystems, and there is another impact that must be considered as well: the creation of low oxygen hypoxia dead zones in the ocean below the farms. These dead zones below the farms are where excess food and waste falls, creating an algae bloom to form, which then decomposes and uses all the local oxygen. Species cannot exist in these zones, which are harmful to marine ecosystems. By focusing on the natural symbiotic relationship between fish and species like sea cucumbers, sea urchins, and marine bivalves such as scallops, clams, oysters, and mussels, which thrive on fish waste, as well as seaweed and kelp for nutrient uptake, these marine mariculture farms can be established below and around the fish farms to eat and filter the fallen waste. As you can see in the image on the right, most species can be farmed in mariculture facilities, indicating that the possible relationships are vast. This combined mariculture practice increases the economic profitability of each area by using it for multiple species farms. It decreases environmental impacts of mariculture by filtering waste and pollution, and it allows these species to contribute their intrinsic value and perform their role in the ecosystem. This is an example of an integrated multi-trophic aquaculture, or IMTA, system like what is pictured below, which is a biomitigation approach to improve sustainability by recycling fish waste through other non-fed, co-cultivated species at different trophic levels who thrive on the waste and absorb nutrients. As shown in the image to the left, the scallops are growing abundantly and thriving on the fish waste. The 2011 NOAA marine aquaculture policy could be more effective in aiding mariculture and IMTA systems if it would add an amendment that prioritizes the development of IMTA systems over coastal aquaculture, so that coastal ecosystems and mangrove forests can be restored, and it should set goals to improve upon IMTA in order to create more natural and sustainable systems with more beneficial relationships leading to better marine stewardship. Traditional aquaculture has not planned for the best marine natural resource management, since it has numerous negative environmental impacts on marine and coastal ecosystems. IMTA is sustainable marine natural resource management through responsible mitigation planning because it will allow for more than one aquaculture farm to exist in the same used area, which will boost economic production, local food security, and seafood exports. Traditional aquaculture goes against the complexity approach by not adhering to the natural limitations or needs of the locations chosen for farming. IMTA will mimic a complex natural ecosystem relationship for these farms to benefit, and it will do so by evaluating the specific needs and limitations to development of each location to avoid harmful impacts and ensure the longevity of ecosystems. Traditional aquaculture does not act according to virtue ethics because it ignores the sensitivity and needs of the ecosystems where farms are located and causes harmful environmental and social impacts. However, virtue ethics can be applied to IMTA because using this biomitigation technique overcomes a defect in the marine aquaculture process and allows those involved to harness a naturally excellent relationship which addresses the sensitivity of the problem within the ecosystem. This IMTA system also demonstrates an understanding of the harmful consequences of current deepwater aquaculture on local species and ecosystems by acting to alleviate this suffering. Traditional aquaculture also hinders the intrinsic value of species by removing them from functioning in an ecosystem. Aldo Leopold's land ethics suggests that societies elaborate upon and diversify the biota and ecosystems to improve their health and longevity, which is what happens by co-farming these species. And he would describe IMTA as ethically right because it will preserve the stability of the community while being more economically efficient. This allows these ecosystems, the global community, and future generations to benefit from the intrinsic value of these species' cohabitation and symbiotic relationship. Traditional aquaculture has inflicted harm in favor of higher production. It has removed species from functioning in their natural relationships, and it has demonstrated the practice of caring for some, not all. The emphasis on the importance of the symbiotic relationship between these species within a community and the need to care for others' environment and food security while not neglecting oneself makes care ethics applicable to IMTA. This also shows responsible development by mimicking a natural relationship and acting as one ought to act for the sake of the ecosystem. And it demonstrates goodness by wanting to reduce the harm being inflicted by current aquaculture and mariculture practices. The image above shows a modeling system used to determine the viability of locations for mariculture, which demonstrates an ethical natural resource management approach, and the image below shows how much more efficient farming fish is to farming other types of livestock, indicating that aquaculture is more sustainable. The 1970 National Environmental Policy Act enables the EPA to regulate aquaculture by setting regulations on pollutants and water discharge that sectors must adhere to or face legal action, and their goal is to restore the integrity of the waters in ways that are economically, ethically, equitably, and sustainably sound for each area. Since IMTA systems are designed with the intent of restoring open ocean integrity by mimicking the ecosystem's natural functioning and filtering waste and pollutants, IMTA aligns with NEPA goals. The 1972 Clean Water Act makes it illegal to discharge any pollutants into navigable waters without a permit, and it regulates how much of what can be discharged to try to minimize harmful water quality impacts. Since IMTA systems discharge waste and pollutants, they will need to acquire permits and adhere to these regulations. The 1972 National Pollutant Discharge Elimination System permit program under the Clean Water Act enables the EPA to regulate aquaculture pollution and waste discharge by mandating the offshore aquaculture operators obtain a permit. Since IMTA systems have discharge that needs to be managed, they must obtain these permits except for very small farms that produce under 20,000 pounds of product, which is unlikely with a cohabitating IMTA system. The 1972 Marine Mammal Protection Act was established to prevent marine species populations from declining past the critical point of no longer functioning in their ecosystem, and NOAA, the U.S. Fish and Wildlife Service, and the Marine Mammal Commission are all responsible for protecting different species and providing different oversight. The goal of IMTA is to create a more sustainable mariculture system which will help marine species populations grow and be healthy by functioning like a natural ecosystem. The 1976 Magnuson-Stevens Fishery Conservation and Management Act governs marine fisheries with the goal of improving their long-term biological and ecological sustainability, and it focuses on preventing overfishing, rebuilding fish populations, increasing social and economic benefits, ensuring food security, and protecting habitats. Even though aquaculture was removed from the definition of fishing, this act still will be relevant to mariculture because it will help build species populations, such as sea cucumbers, increase the economic benefit of each mariculture facility by farming more species, and provide local and global food security to communities who rely on seafood. The 1980 National Aquaculture Act made aquaculture a priority for the USA and created the Subcommittee on Aquaculture through which NOAA coordinates with the EPA, U.S. Army Corps of Engineers, USDA Animal and Plant Health Inspection Service, FDA Center for Veterinary Medicine, FDA Center for Food Safety and Applied Nutrition, and the U.S. Fish and Wildlife Service regarding aquaculture priorities and processes. Any mariculture and IMTA facility will have to coordinate with this subcommittee and these federal agencies to ensure their methods are up to date. The 1987 Brundtland Commission declared that sustainable development must meet current needs without compromising the ability of future generations to meet their needs as well. So sustainable development must prioritize global and generational equity, which co-operating mariculture farms achieve by being less environmentally impactful and more economically effective. The 2007 National Offshore Aquaculture Act requires permits for the development and operation of offshore aquaculture facilities in U.S. exclusive economic zones, removes aquaculture from the fishing category under the Magnuson-Stevens Acts, and demands further research and development into mariculture technologies that protect marine ecosystems. Any offshore aquaculture system, including IMTA, will need to acquire permits before constructing and operating an offshore facility. Lastly, the 2011 NOAA Marine Aquaculture Policy specifies goals, priorities, and objectives for all aquaculture activities to promote marine stewardship, and it includes a list of steps for NOAA to take to achieve its goals. Mariculture facilities will need to follow this policy to be sustainable and help achieve global ocean protection goals. Global seafood demand is increasing as the human population grows by billions within the century. Since aquaculture already provides around half of this demand, and since it will likely need to provide more as awareness regarding overfishing spreads, the current unsustainable practices and harmful environmental impacts of aquaculture must be mitigated. Climate change impacts will get worse unless society can find ways to mitigate current harmful practices and preserve natural healthy ecosystem relationships, has a history of sustainable success, as you can see in the image to the right. Some species, like sea cucumbers, are seeing their population numbers threatened due to the medicinal properties and high cell values, so not only will incorporating them into IMTA help restore their populations, but it will also provide another reliable source of food and income for global society. Mariculture farms can be established with little environmental impact and be powered by renewable solar and wave energy as long as proper marine spatial planning occurs. So moving aquaculture farms offshore and establishing them as IMTA mitigates the harm being done to coastal communities while ensuring nutritious food security from increased aquaculture production and boosting local and global communities. IMTA is the future of aquaculture. Thank you for listening.